In this video, we are going to go over how to solve a system of linear equations by graphing. And on the flip side of the video, I'm going to give you a bonus problem. So let's do two problems just to make sure we get it down pat. The basic idea is we want to know where two equations of lines intersect. The reason for that, in a previous video, we went over that the solution to a system of linear equations occurs when both lines have the same exact values for x and y that work in those two equations. Well, graphically, that would mean that both lines occupy the same exact point or go through the same exact point. So we want to know where those lines intersect. So what do we do to figure that out? We graph them each individually. So this is no more difficult than simply graphing this, graphing that, and seeing where they intersect. One piece of advice, when you graph out this system of linear equations, each one of these, graph out a whole bunch of points for each line, because if you just freehand draw the graph, you might not get an accurate intersection of the two lines. That's actually one of the weaknesses of using graphing as the technique for solving a system of linear equations is there's a little bit of error. So if our line's off by even just a little bit, our intersection point might not be accurate. So there are other ways to solve systems of linear equations. That is either in future math classes or in future math videos. Let's check this out. So I'm going to graph y equals 2x minus 2. So 2x minus 2 has a slope of 2 and a y-intercept of negative 2. So I'm just going to kind of focus on that for a second. So my first line has a slope of 2, which is 2 over 1, and a y-intercept of negative 2. So let's graph it. Well, my y-intercept is negative 2, so I'm going to go down 2. Graph a point, and now I'm going to observe the slope in both directions, right and left. So this tells me to go up 2, right 1. So I go up 1, 2 over 1, 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 plot a whole bunch of points, up 2 over 1, because we don't know where the solution is going to be. So I'll go down 2, left 1, down 2, left 1. It's quick enough. Now, I'm not going to draw out the line yet, because I just want to kind of have an open mind to where the points might intersect. You'll see what I mean in a moment. Now I'm going to graph this line, y equals 1/2 x plus 4. So in this line, the slope is 1/2, and the y-intercept is 4. So I go to the y-intercept of 4, that's up 4 right here, and I'm going to have a slope of 1/2, which means go up 1 and right 2. Up 1, right 1, 2. Right away I'm seeing that I don't need to draw the line to the left because it looks like we're going to intersect somewhere over here. I'll continue with my slope of up 1 over 2. Up 1 over 1, 2. Oh, they intersect right there. Up 1 over 2. So I know they intersect here because I landed on the same exact point for this line that I had already had drawn for this line. So if you want, just to complete this, draw a rough sketch of the lines. But it really doesn't matter how accurate your line is in terms of hitting all those points because we've already determined that our point, our solution is right there. All we have to do is locate what point that is. Well, that's over 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. So right 4, up 6, our solution is x equals 4 and y equals 6. Or another way of putting that is 4, 6. Okay, so that's the solution. The question is, how do we check to see if we're right? It's very simple, and I'm going to show you that right now. We take the x value of 4 and the y value of 6 and input them into the variables right here. So let's do that. I'm going to take 4, 6 and put it in here. So 6 is in for y, and x will be 4. Very cool. So that's going to be 2 times 4 minus 2. Let's evaluate this. 2 times 4 is 8. Minus 2 is 6. And that's a true statement. 6 equals 6. Sweet. So 4, 6 is on the first line. Let's check out this line here. So we will plug in 6 for y and 4 for x. We do that, and now let's simplify. 1/2 of 4 is the same as dividing 4 by 2, which is 2, plus 4 is 6, which is equal to 6. Both of these equations are true when we evaluate x equals 4 and y equals 6 into them, so our graphs are correct and our solution is indeed 4, 6. On the other side of this video, I'm going to have a second example a lot like this one, but a little different in that I'll give you a little different of a setup for the equations, maybe one that's not quite in slope-intercept form that you have to adjust for. Regardless, this is the overall how to solve a system of equations by graphing. And now on the other side of this video, I'm going to go over how to graph to find the solutions to another system of linear equations. The difference this time is this system of linear equations has one linear equation that is not in slope-intercept form or y equals mx plus b form. No sweat. Let's just get this in a slope-intercept form. And that brings me to one piece of advice I would give. If you're given other options in your math class to solving system of equations down the road, the option of solving by graphing is probably the least accurate, but the best way to visualize what's going on that you're looking for where the lines intersect. If your equations are not both in slope-intercept form, get them there. I think it's easier to graph them that way, or maybe that's an indication that you should be using a different method, if given the choice, to find the solution to the system. All right, with all that said, let's solve minus 3x plus y and put it into y equals mx plus b. So I write out the form that I eventually want to get to. I want y equals mx plus b. Now how do I get this to that? Well, if I could move the x term over to the right-hand side of the equation, I would have it in the form y equals mx plus b. To do that, I'd have to add 3x to both sides. So I'm going to do that to both sides. I guess I'll take this equation, I'll rewrite it here. And then I'll add 3x to both sides. Beautiful. The 3x's cancel out, and we're left with y equals 3x and minus 1 are not like terms, so we have 3x plus a negative 1, or minus 1. So now what we've done is we've taken this equation and rewritten it like that. So if we're graphing the equations, we're graphing this one and that one, but by graphing this one, we're really getting the graph of that guy right there. Let's do it. Remember, all we're looking for is where these lines intersect, and the main idea is plot as many points as you can for both lines so that you're not trying to see where your lines intersect, but you can hopefully just run right up on the point where they do intersect. Let's do this. We'll graph y equals minus x minus 5 first. The slope of that is negative 1, which would translate to negative 1 over 1, and the y-intercept would be negative 5. So let's put b equals negative 5 down here. That would be 1, 2, 3, 4, 5. Perfect. And then our slope of negative 1 would be down 1, right 1. Okay, so down 1, right 1. Down 1, right 1. And down 1, right 1. And let's go in the opposite direction too, just in case the intersection's somewhere over here. Up 1, left 1. Up 1, left 1. Up 1, left 1. And we just keep going like that, and so on and so forth. And maybe we need more points. Who knows? We'll see after we graph the second equation. Now we're going to graph this equation here, which we've translated to y equals 3x minus 1. The y-intercept we see is negative 1, and the slope is 3, which is the same as 3 over 1. So I'll start at negative 1 and then rise 3 and run 1. So I'll start at negative 1. If I rise 3, 1, 2, 3, and run 1, I'm going to stop graphing in that direction because all the rest of the points are up here and the other line's down here. I'm going to go in the opposite direction now. So now instead of going up 3, right 1, I'm going to go down 3, left 1. So down 1, 2, 3, left, oh, right there. It occupied the same point. We'll keep going, down 1, 2, 3, left 1. But we already have that the intersection is right at that point. So you could draw out a line that's relatively straight on both of these, but honestly, it does not matter how straight your line is at this point because we've already found that that's our location where both lines have that point on it. So what is that point? It's left 1, down 1, 2, 3, 4. Left 1, down 4. So that would be negative 1, negative 4. So our solution is when x equals negative 1 and y equals negative 4. As I showed in the earlier part of the video, we can check our answer. I'm going to check it always in the original two equations so that just in case I altered this one incorrectly, my check will show me that there was an error. So we want to check the original equation. So I've got negative 3 times the x value, which is negative 1, plus the y value, which is negative 4. And the question is that true? Well, negative 3 times negative 1 is 3, plus negative 4 is negative 1. Sweet! So negative 1, negative 4 is a solution to that upper equation. Let's see if it is for the bottom one. Y is negative 4, right? Evaluating y in for that. And that's equal to the opposite, that minus sign of the x value, negative 1 minus 5. Well, is this true? Well, the opposite of negative 1 is 1, minus 5 is negative 4. Sweet! That means that this is the solution. We found it correctly with our graphs, and we are happy. I hope you're happy too.